Okay, so you should have gotten the point -2, 8, -1, 2, 0, 0, 1, 2, 2, 8. So if you compare this graph to the very first graph we made on the first page, you can tell it's skinnier. Okay, it got stretched by a factor of 2. Now, let's look at the next one where we have 1/2 in front of the x squared. Okay, we still say that it's stretched by a factor of 1/2. So stretched by a factor of 1/2. But I want you to use your table to find some really good points to see what this parabola actually looks like. So once again, 15 seconds. Go to your table, find some good points. Okay, make it quick. Okay, so some good points you should have found would be, let's see, 1, 2, 3, 4, -4, 8, -2, 1, 0, 0, and then the parabola starts coming back up. So 2, 1, 4, 8. So compare this parabola to the very first graph that you saw on these notes, your parent function. And you see how it's wider? So technically it's stretched by a factor of 1/2, but since the factor is less than 1, it's actually being shrunk, I guess you could say. So it makes it wider. So you can always say it's stretched by a factor of whatever number's in front. If you would rather say, like, if the number's bigger than 1, that it's narrower, I'm fine with you saying that. If the number in front is less than 1, if you want to say it's wider, that's fine with me too. Either one. This is just easier to remember. Anytime you have a number in front, it's stretched by a factor of whatever it is. It's a lot easier to remember. So. But either one, it's up to you. So the next part of your notes, we're going to list what happens whenever we do certain things to the equation, like what effects happen. Okay, so we're going to list that out. That way you have it there all together in one section. Okay, so the first one, if I have a negative in front of the x squared, we said it's reflected over the x-axis. Anytime you have a negative in front, it's going to be flipped upside down. So if that helps you remember it better, if you want to say it's flipped upside down, go ahead and put that. These are your notes, so whatever helps you the most. Okay, the next one, if I have x plus h in parentheses in the squared outside, we talked about how if it's inside the parentheses, it's going to move it left or right because it's with the x. Anytime it's with the x, it's going to move on that x-axis, right? But it does the opposite of what you think. So the plus h is actually going to move it left, whatever that number is. The minus h will move it to the right. And then if you have a number outside the parentheses, if it's at the very end and we're adding or subtracting it, so like plus k or minus k, that's going to move it up or down. So the plus k will move it up and the minus k will move it down. And then the last one that we talked about is if you have a number in front of the x squared or in front of your parent function, it's going to stretch it. So this is going to stretch it by a factor of whatever that number is. Okay, and like I said before, this should be review, but I do want to go back over it, that way we're all on the same page. Okay, so let's go to the next page. We're going to practice with multiple transformations, like putting a negative in front, putting a number in the parentheses, and a number at the end, and drawing that graph. Okay, so go to the next page. Okay, so on the first one, what I like to do is anything that's different in the equation than the parent function, I like to label it with how it makes it move. So like our parent function doesn't normally have a negative in front, right? So what is the negative going to make it do at the very beginning? It's going to flip it. The minus 3 in parentheses, what is that going to make it do? It's going to move it to the right. Remember, it does the opposite. So it'll go to the right 3, and the last number is going to move it up 1. So what I do is I go through that whole equation and I say what each thing makes it do. Okay, and now I'm going to graph it. So to graph it, I'm going to take my original function, which has the vertex at the origin, 0, 0. So I'm going to take that vertex and I'm going to move it right 3 and up 1. So when it's normally here at the origin, I'm going to move it right 3 and up 1. And that's my new vertex. Now, because of that negative in front, it's not going to be a right side up parabola. It's going to be upside down. And we aren't going to do the table. I just want to see that you know what you're doing. So I don't really care about exact points. I just want to see like right 3 and up 1. Okay. Okay, and then on the domain, these are your x's. Okay, it's going to go to the left forever and ever and to the right forever and ever. So it's going to be negative infinity to positive infinity, or you can say all real numbers. Now, for quadratics, your domain will always be negative infinity to positive infinity, or all real numbers. So if you see a problem with x and squared, you can go ahead and put the domain right then, because it doesn't matter if I move it up, down, left, right, flip it, stretch it, whatever, my domain will always be this for quadratics. So range is a little different. Range is the lowest to the highest. So my lowest point, see how my lowest values, there's an arrow there? That means it's going to keep going forever and ever. So it's going to go down forever and ever, so negative infinity. And then my highest point, it's going to go all the way up to where y is 1. So negative infinity to 1. And that one's going to have a bracket, okay, because there's actually a point there, okay? Or you could say that y is everything less than or equal to 1. Either one. Okay, the next example, I'm going to go through each part of that equation that's different from x squared, my parent function, and say what it's going to make it do. So the 2 is going to stretch it. The plus 4 is going to move it left. Remember, it does the opposite. And the minus 2 will move it down 2. Okay, so the way we're going to graph it is we're going to take that vertex, we're going to move it to the left 4 and down 2. So it's normally at the origin, we're going to go to the left 4 and down 2. Okay, so that's my new vertex. Now, before I make my parabola, I would have to think, okay, is it right side up or upside down? Okay, and this one's going to be right side up, but it's going to be stretched. by a factor of 2. So it's going to be a little bit skinnier. So it should look like that. Okay, I don't care about exact points, but I should be able to see left 4, down 2, should be a little bit skinnier. Okay, stuff like that. Okay, my domain for quadratics is always all real numbers. You can put negative infinity to positive infinity or all real numbers. It's totally up to you. The range is my lowest to the highest. So my lowest point here is -2. Okay, and it's going to have a bracket because I have a point there. And then it goes up forever and ever. So it goes all the way up to infinity, parentheses. Or you could say that y is going to be everything greater than or equal to -2. Okay, either way. Okay, the next thing we're going to do is write equations for quadratics based on the translations they give us. Okay, so let's look at that. Let's start at that first example. Okay, and on the first example, it says that it's shifted 3 units left and 6 units down. So here's the thing. If we're talking about quadratics, it has to have an x squared somewhere. That's how you can tell if it's quadratics or not. So on number 1, well, on all quadratics, make sure you have that squared, okay? Or else, I mean, it's not quadratic. You won't get a parabola. So it needs to go to the left 3, which means that that's going to be inside the parentheses. And it does the opposite of what you think, okay? So y equals x plus 3 squared. That's going to move it left. And down 6. So -6 will go at the end. Okay, number 2. Number 2 says reflected over the x-axis and stretched by a factor of 3. Both of those transformations need to be written before the x squared. Okay, if I'm going to reflect it over the x-axis, I'm going to have a negative at the beginning. And if I'm going to stretch it, I'm going to have a 3 at the very beginning. So this would be my answer. Y equals -3x squared. Okay, number 3, reflected over the x-axis, shifted 3 units right and 2 units up. Okay, so if I'm going to reflect it, I need a negative at the beginning. If I'm going to move it 3 units to the right, it has to be in parentheses. So x minus 3 squared. Don't forget the square. And then that minus 3, the reason we did minus is because it does the opposite. Okay, and then the last part, 2 units up, so plus 2 at the very end. Alright, number 4, we're going to reflect it. We're going to stretch by a factor of 2, shift it 2 units to the right and 3 units up. So we're talking about all the transformations all in one equation. So let's start with reflecting it. Okay, we need a negative at the beginning. Then we're going to stretch it by a factor of 2. So we're going to multiply at the beginning by 2. We're moving it 2 units to the right. So that should be x minus 2 squared. That'll move it to the right too. And then 3 units up. So plus 3. Okay, so this is something you'll be doing on your worksheet today. You'll have to write the equation for the quadratic.